Hey guys, in this video, we're going to be talking about measure of center and measure of variability. Remember, measure of center is when it's in the center of the data, either mean or median, and then variability is how much it varies, and we'll talk about those in a second. So the two different measures of center are going to be mean and median. Remember, the mean is the average, the median is when you cross them out till you get to the number in the middle. Measures of variability are MAD, mean absolute deviation, or interquartile range. The mean and the MAD are going to go together, and the median and the IQR are going to go together. So if it's the mean for this measure of center, it's going to be MAD for the measure of variability. And if it's median, it's going to be interquartile range. Okay, so looking at this data, we need to figure out what is the best measure of center. Well, because in this situation, we've got some outliers, we are going to use the median. And because we're using the median, we're going to use the interquartile range. So we could put all these numbers in order, cross them off to get to the middle for the median, then cross off to get our lower quartile and our upper quartile, and subtract them to find the interquartile range. Because there is an outlier, that's why we're using median, because if we kept it with mean, it would be skewed because of the outliers. So in this data, we've got a bell curve going up and down. So its measure of center is just mean. We can add them up and divide by how many there are. And because we're using mean, we can use the mean absolute deviation to tell us how spread out or close together the data is, how much it varies. Variability. This one has an outlier. So what's your guess? What do you think it's going to be? I hope you got median because you're right. Because it's got an outlier, it's going to be median. And then with median, we always do interquartile range. Okay, try this one. It's going up, it's going down. There are not any outliers, so we would use the mean. And we would use the mean absolute deviation. So this one's got a little sneaky guy out there. It's got an outlier, so we would use the median and the interquartile range. Okay, so this one's a little bit different. You've got a list of data. Notice, do we have an outlier? Yes, we've got a 32. So because we have an outlier, we've got to use the median and the interquartile range. Okay, so this is going to take you a little bit of time. So I want you to pause the video now, and I want you to find the original median and the original mean of these data, of this data set. I hope you paused it. You should be doing this on your own now. Okay, welcome back. We're going to start by finding our originals. So we're going to put our numbers in order: 85, 89, 90, 90, 100. We're going to add them up. Just use your calculator. Remember, 85 plus 89 plus 90 plus 90 plus 100. I'm going to do that again just to double check it. 85 plus 89 plus 90 plus 90 plus 100. Very good. We're going to divide it by 4 because there's, or 5 because there's 5 numbers, and we get 90.8 for original mean. And for our original median, we're going to cross them off and we get 90. Okay, so now we're also adding in another 98. So we're going to rewrite our numbers. 98 and 100. So I'm going to take my previous answer, 454, and I'm going to add 98 because I already did that math. So it's 552 divided by 6 numbers now, and we get 92 for our new mean. So notice, we'll talk about that in a second. Now we're going to cross them off to get the new one, which is also 90. because there was 2 numbers in the middle. So what changed in the median? Nothing. It stayed the same. Then between the means, we had 92 minus 90.8. So again, use your calculator. 92 minus 90.8, and our change was increase. I'm going to erase and write the word. By 1.2. So make sure you've got all that work on your paper.